last video of the AAI ATC physics solution series. In this video I am going to demonstrate 7 problems of 2021 ATC paper. Hope you will enjoy it. So let's look at the 31st problem, which says that what will be the electric field intensity at a point P due to a short dipole if the dipole is placed in a air or vacuum. So as we know, the potential due to a dipole is like 1 over r square, and since the electric field is proportional to del V del r, so the electric field will be proportional to 1 by r cube. So as you can see, this is required in the air or vacuum, so there is no factor like k should be there in the answer. So only one option fulfills the requirement for the answer, and that is option A. Now the question is, a hydraulic lift is used to raise a car of mass 200 kilo, and suppose there is a lift here, there is a car, and the area of cross section is given, and what pressure the smaller piston has to bear if the bigger piston is 2 meters higher than the smaller piston. The smaller piston is here where you are pushing something, and there is some kind of liquid is connected or something like that. So as we know from the Pascal's law, the pressure in the liquid has to be same, and the only pressure difference between these two hydraulic lifts is because of their vertical distance. So the pressure in the bigger lift is basically the force, which is 2000 into 9.8 divided by 375, which is given in centimeter square. Be very careful here. So you need to multiply a factor of 10 to the power minus 4. So pressure on the smaller lift would be P1 plus rho g times 2 meters. So if you put the value of rho, which is 800 kg per meter cube, and g, and calculate P1, it is easier to show that the answer would be option C. Question 33 says, an object is placed in front of a concave mirror of radius of curvature is given at two different distances, 10 cm and 5 cm. So determine for which of the cases the image is magnified, virtual and erect. So you need to know the information that for a concave mirror, the focal length is like, if the focal length is here f and this is 2f distance, so if an image is somewhere between 2f and infinity, then if an object is between 2f and infinity, then its image would be something between f and 2f, and it would be not magnified, it would be smaller than the object, and it would be inverted. Now if an object is placed between f and 2f, then its image is produced somewhere between 2f and infinity, okay, and it would be also be inverted. And if something is placed between focal length of the mirror, then the image is virtual and it is erect and it is magnified. So in this case, the radius of curvature is given 15 cm, so the focal length is 15 by 2, which is 7.5 cm. So we have to place the object between the focal length and the mirror, which is in the case of 5 cm, this fulfills the requirement. So only if the object is placed in 5 cm, then the image will be magnified, virtual and erect. So option B is correct. Now let me describe the 34th problem first. That there is a straight wire which has a charge per length lambda, and then there is a hollow metallic cylinder which has a charge per unit length is 2 lambda. Now you need to calculate the electric field at a distance r from the straight wire. Now we know from the Gauss law that the electric field in a metal surface is 0. So think the hollow cylinder like this. It has an inner surface, it has an outer surface, and the wire is passing like this. So now you can imagine a Gaussian surface in the metallic part of the hollow cylinder here. So as we know that the electric field here would be 0, that means the total flux passing through this Gaussian surface must be 0. So the metal would have a charge density in the inner surface, charge per unit length in the inner surface induced by this positive charge minus lambda. So to conserve the charge, the outer surface will contain a charge of 3 lambda. So 3 lambda minus lambda is 2 lambda. So now you can imagine a Gaussian surface at a radius r like this, and as you know, you need to use the Gauss law, which is E, and integrating the ds, let me write it down, that is the net charge, which is 3 lambda by epsilon naught into per unit length is L. Then E is ds each pi r square times L. L is the length of this Gaussian cylinder, which is 3 lambda L by epsilon. So if you simplify this pi r square goes down here, L cancels out, and the electric field would be radially outward. So option B is correct. The next question says a point possesses simultaneous velocities whose measures are 4, 3, 2, 1. The angle between the first and second is 30 degree, between second and third is 90 degree, between third and fourth is 120 degree. We have to find out the resultant velocity. So first let's plot the vectors in this xy plane. So the first vector is of magnitude 4, and the second vector is of magnitude 3. This makes an angle of 30 degrees. Then the third vector is of magnitude 2, and between third and fourth, somewhere here is your fourth vector. So you need to calculate the components basically. So the resultant component along x direction would be 3 plus rx is 3 plus 4 cos 30, which is root 3 by 2, minus this angle is 30 degree because this angle is 90 degree and the total angle is 120 degree. So again root 3 by 2, that is 3 plus root 3, right? No, sorry, 3 root 3 by 2, and ry would be 2 minus half, which is minus half. So if you calculate this, and the resultant magnitude is rx square plus ry square, you will see the answer would be 5.62. So only the option A is correct. We don't need to even carry out the angle, right? So now the question is that point is moving with a uniform acceleration in the 11th and 15th second from the commencement. It moves through 640 and 840 centimeters respectively. Find its initial velocity and acceleration with which it moves. So basically you need to know this formula, that in the nth second the particle moving with a constant acceleration actually moves through the distance Sn, which is basically u plus n minus half by into a. So you can show this by showing that Sn is un plus half a n square and Sn minus 1 is un minus 1 plus half a n square. So if you subtract this, let me denote it by delta Sn. So delta Sn is basically Sn minus 1, and if you simplify you will get this. So you have to put these values. 640 is u plus 10.5 a, 840 is u plus 14.5 a. This is 2, this is 1. We are subtracting 1 from 2. We will get 200 is u plus 4a, and a is going to be 50. So there is only one option with 50 centimeter per second square. So option D is the correct answer. And this is probably the most lengthy question of this paper, 37, which says that a point charge q is located on the axis of a disk of radius r at a distance b from the plane of the disk as shown in the figure. Find the value of r if 1/4 of the electric flux from the charge passes through the disk. So here let me draw the disk and consider an infinitesimal annular region in the disk. Okay, and you have a charge here. Charge here, the distance is b, and the electric field is always radial, so the electric field looks like this. Then the area vector is this, so their angle is theta, which is same as theta. Sorry for bad drawing. So we need to calculate first the flux through this annular region. Okay, so that is d phi is 1 by 4 pi epsilon naught, and this distance is basically b square. If the annular region is at r to r plus dr, then this distance would be b square plus r square. So this is q by b square plus r square into 2 pi r dr, which is the area of this annular region, times cosine theta. Now this is 1 by 2 epsilon 0 q r dr. Cosine theta is basically this divided by this, so that would be b divided by b square plus r square into b square plus r square whole to the half, which is b square plus r square to the 3 halves. Now to get the whole flux, you need to integrate this phi from 0 to r, so that would be q by 2 epsilon 0 b r dr b square plus r square whole to the 3 halves, and this would be 0 to r. Now you substitute r square as u, so this integral becomes qb by 2 epsilon 0, take out a factor 1 by 2, this is d of u plus b square over b square plus u to the 3 halves from 0 to r square, and that would be qb by 4 epsilon, and then this should be b square plus u whole to the minus 3 half plus 1 by minus 3 half plus 1. So that would be the total flux. So you please simplify this, and this is 0 to r square, and we need to find out what is the value of r for which phi is 1/4 of the total flux. So 1/4, and the total flux is q by epsilon naught. And if you solve this equation, you will get something like 4b square is equal to b square plus r square type of thing, and then r is root 3b. Option D is correct. Thank you for watching the video. If you have anything in your mind, you can comment it down, and if you like this video, please like, share and subscribe. Thank you for watching.